So let's say you are seated peacefully in the exam, minding your own business, and they decide to ask you to use the definition of the derivative in order to prove that the derivative of cosine x is negative sine x. So the first thing you do is to allow f of x to be cosine x. And this is how we define the derivative of a function. It's the limit as h approaches 0 of f of x plus h minus f of x. And this whole thing is divided by h. So in order for us to get f of x plus h, we just replace x with x plus h. So in other words, it's now the cosine of x plus h. And then we say minus cosine x. And the whole thing is divided by h. And if we give it a good look, it seems like we have hit a dead end. But then we remember what we learned in grade 1. We said every time we have the cosine of a plus b, and back then we used to call this the compound angle formula for cosine. So we used to say this is cos A, cos B, and then we say minus sine A times the sine of B. So we are just going to use this and apply it on this limit. So here we get cos x times cos h, and then we say minus sine x sine h. And we still have minus cosine x. Of course, this whole thing is divided by h. This is what we have. Then from this point, we are just going to be a little bit observant. So we can see that between these two terms, there is a common factor. So we want to take cosine x out as the highest common factor. After taking cosine x out, from the first term, we are left with cosine h. But from the second term, we are just left with a solid 1. Of course, we still have sine x times the sine of h. And this whole thing is divided by h. This is what we have. Then from this point, we are just going to separate the two fractions. So when we separate the two fractions, we are now going to separate the two limits. You'll see that. So it's just going to be the limit as h approaches 0 of cosine x into cosine h minus 1. And this is divided by h. And then we say minus the limit as h approaches 0 of the sine of x times the sine of h, and we say everything is divided by h. Do you see that? Well, what I used here is the simple principle that if you have a plus b over c, this is exactly the same as a over c plus b over c. So that's just what I did. Fine stuff. I'm just going to get rid of the top part so that we can take this further. So I want you to see what I'm going to do. Remember, if you have half x like that, well, this is the same as having x over 2. Do you agree with me on that? So if you agree with me, then you will also agree if instead of me writing cosine x times cosine h minus 1, I'm just going to write this as cosine x times the cosine of h minus 1, which is divided by h. Do you see that? And I'm going to do the same to the second quotient. So I'm just going to say I have sine x times the sine of h over h. Oh, I actually forgot an h here. Fine stuff. And at this point, I can see that I actually have a limit of a product of two functions. So according to the limit laws, this will just be the product of the limits of these two functions. And of course, I do the same on the second part. So I say it's the limit of sine x times the limit of sine h divided by h there. And then what do we say from this point? Easy stuff. So if you give this a good look, you can actually see that cosine x is just a constant. Why? Because the variable we are working with is actually an h in the context of the limits. So once you realize that cosine x, it's just a constant, well, the limit of a constant is a constant. And this one is actually a special trigonometric limit. So every time you see a situation like this, you must know that it's an identity. And the value of this identity is a solid 0. Then once again, the limit of a constant is a constant. And this one as well is a special trigonometric limit. It's an identity as well. And every time you see that, you actually see a 1. So 0 times cosine x will be 0. Sine x times 1, it's just negative sine x. So you have actually shown that the derivative of cosine x is negative sine x. Well, you can choose to write it nicely if you like and say, therefore, the derivative with respect to x of course of cosine x is just negative sine x over and out.